Hello everyone, this is Bharat Kumar. In this video, we are going to see Cohen-Sutherland algorithm. So let's start the video. The content we are going to see in this video are the introduction to the algorithm and the algorithm. Next, we are going to see the implementation using the program and the output of the program, and at last, the conclusion of the program. So the Cohen-Sutherland line clipping algorithm is a widely used method for line clipping in the computer graphics. The main idea behind the Cohen-Sutherland algorithm is to represent the clipping window as the rectangle divided into 9 regions, and each region is assigned a 4-bit binary code known as the outcode that describes the location of a point related to the window. The outcode is calculated based on whether the point is above, below, to the left, or to the right of the window. So according to the introduction, the Cohen-Sutherland algorithm is used for clipping of a line, and the window is divided into 9 regions. Okay, and each region is represented using a 4-bit binary value, and this 4-digit binary value is called the opcode. And the first digit of the opcode represent the top value, the second digit represent the bottom value, and the third digit represent the right value, and at last the fourth digit represents the left value. And in short, we can call it as TBRL. Okay, and this is the Ymax value, and this is the Ymin value, and this is Xmin value, and this is the Xmax value of the window. Okay, so now let us look at the algorithm. In the step 1, we are going to calculate the position of the both the endpoints of the line. Then we are going to perform OR operation on the both the endpoints. If the OR operation gives us a 0000 value, which is the value of a window, then we can say that the line is visible to us. Okay, else the perform AND operation on the both the endpoints. If AND operation doesn't give us 0000, then we can say that the line is invisible, means it is out of the window. Else the AND operation gives us 0000, we can say that the line is partially inside, or considered as a clipped case, means half part of the line is inside the window and the half part of the line is outside the window. Okay, and in the step 4, if the line is in the clipped case, then we are going to find the intersection with boundaries of the window. First we are going to find the slope of the window. Okay, using the formula m is equal to y2 minus y1 divided by x2 minus x1. So uh, there are actually four cases. There may be the line may be at the top, or at the right, or at the bottom, or at the left. Okay, so according to that cases we are considering here. So first we'll consider the bit 4, which is a left bit. If it is 1, the line intersects with the, we can say that the line intersect with the left boundary of the rectangle window. Okay, so we can find that intersection using the formula y3 is equal to y1 plus m into x minus x1, where the x value represent the coordinate of the window. Okay, then if the bit 3 is 1, we can say that the line intersects with the right boundary, and we can find the right intersection point using the formula y3 is equal to y1 plus m into x minus x1, where the capital X represent the x coordinate of the window. And next, if the bit 2 is 1, then the line intersects with the bottom boundary, and we can find this bottom intersection point using the formula x3 is equal to x1 plus y minus y1 divided by m, and where the y represents the y coordinate of the window. And at last, if the bit 1 is 1, then we can say that the line intersects with the top boundary, and we can find using the formula x3 is equal to x1 plus y in minus y1 divided by m, where y represents the y coordinate of the window. So now let us look at the implementation of Cohen-Sutherland algorithm using a OpenGL program. First, we are going to include a header file. Then we are going to declare the x and y coordinate of the window, which is xmin, ymin, xmax, and ymax. Then we are going to declare the coordinates of the line, which are x0, y0, x1, and y1. Then we are going to initialize the right, left, top, and bottom value with respect to window, which are 8, 4, 2, and correspondingly. Then we are going to declare the Cohen-Sutherland function, which accept the parameters x0, y0, x1, and y1, which are the coordinates of the line. Then let's see the next part. Here the outcode, which is the 4-digit binary code. The first outcode 0 represents the one end point of a line, and the next outcode 1 represent the next end point of the line. Okay, if the line has two endpoints, one is outcode 0 and the another is outcode 1, and the outcode out is the point which is outside the window. Okay, then we are going to initialize the accept value boolean value, which is accept value as the false and the done value also as a false, and we are going to initialize the outcode 0 using the value written by the compute outcode function, and also outcode 1 with the value returned by the compute outcode 0. So next is the do while loop. So in do while loop we are going to check for the certain condition according to the algorithm. So first, if the negation of the outcode 0 or outcode 1 is true, then we are going to change the accept value as true and the done value as true. Else if the outcode 0 and outcode 1 value is true, then we are going to only change the done value as true. Else if both the condition are not satisfied, then we are going to change the outcode 0. Whether the outcode 0 1 is true, then only the outcode 0 is initialized as outcode out. Else if the outcode 0 is false, then we are going to initialize the outcode 1 value to the outcode, means it is a ternary operator. Okay, so when we after finding the outcode out value, we will check with respect to the outcode out value whether it is at the top, bottom, left or right. If the outcode out and top gives us true, we are going to assign the corresponding formula and find the x value, and also assign y as x y max. Else if the outcode out and the bottom gives us true, we are going to find the x value with the corresponding formula and assign the y value as the y min value. Okay, else if the outcode out and right values gives us true, we are going to calculate the y value with the corresponding formula and we are going to assign x as x max. Else if all the conditions are not satisfied, we are going to calculate the y value with the formula and x value is assigned as a x min. Then we are going to check either if the outcode out is equal to outcode 0, then if yes, then we are going to assign x naught value as x and y naught value as y, and outcode 0 is calculated using the function compute outcode x naught y naught. Else if the outcode out is not equal to outcode 0, we are going to assign x1 value as x, y1 value as y, and the outcode 1 is calculated using the function compute outcode x1 comma y1, where the x1 and y1 are the coordinates of a line. Then we are going to check if the accept value is true. If true, then we are going to set the scaling coordinates of the window. Then we are going to set the color of a line, which is red. So here there are three parameters RGB, where R represents the red, G represents the green, and B represents the blue. So the first R value is set as 1, so the color of a line becomes the red. Then we begin to draw a line. Here we draw the line with respect to the corresponding points that we have already calculated. So now we are going to calculate the outcode value using outcode function. So first we are going to check whether the y value is greater than y max value. Here the y value represents the y coordinate of a line, and y max value represents the maximum y coordinate of a window. Okay, if the y value is greater than y max value, then we can say that the outcode is equal to top, means the line point is at the top of the window. Else if the y value is less than the y minimum of a window, okay, then we are going to say that the code value, means the line point, is at the bottom of the window. If the x value is greater than the x max of a window, then we are going to assign the code value as a right. Else if the x value is less than the x min value, then the code value is assigned as a left. Then it returns the code to the calling function. So next we have a display function. Here we are going to call the GL clear, which is used to clear the buffer bits allocated. Then we are going to call GL color 3f, which is used to assign the color to a line. Then we have a GL begin function, which is used to draw the line based on the corresponding coordinate values. Then we are going to call the Cohen-Sutherland function, where we have passed the x coordinate and y coordinate values. Then we are going to call the GL flash value to immediately execute all the parameters passed and all the processes to be taken out. Then we have a my init function, which is used to initialize the values. In the my init function we have GL clear color. So This function clears all the screen value to a white, means the screen turns into a white color. Then we have GL matrix mode, which is used for a projection of a screen to the window. So this is the main function. In the main function, first we are going to ask the user to enter the endpoints of the line. Then we are going to accept the user input. Based on the user input, we are going to initialize the argument character and values, and also the display mode, window size, and window position. Then we are going to create a new window naming Cohen-Sutherland line clipping. Then based on the user input, we are going to call the glad display function and also my init function, which draws the line correspondence to the algorithm. And this is the end of the program. So here you can see the output of the program. First the line was from here to here, but after applying the Cohen-Sutherland algorithm, the line has got clipped according to the user input. So from this video we can conclude that the Cohen-Sutherland line clipping algorithm is relatively simple, efficient, and can handle various types of clipping window. And also it is used for efficiently rendering the line segments that are partially or completely inside a rectangular viewing window. So that's all for this video. Thank you for watching.